Okay, today what we're doing is similar figures. So first we need to discover what is a similar figure. Well, we already know what congruent figures are, right? We know congruent figures are straight copies of an image. So, are those congruent? They're the same image, right? Are these congruent? Yeah, it's the same image, just rotated, right? So we know congruent has same shape, same sides, or same size, same shape for congruent. But what if we do this? We keep the shape, but we make it bigger. It's the same shape, just blown up. That is what we like to call similar. These two images are similar. This is still similar, right? But what if we do this? What if we do this? We make this. We change the shapes. Are these similar now? No. These aren't related to each other at all. It's different shapes. And different size. But it's a different shape. Okay. Well, there you go. Off your phone, please. So, okay. So in order to prove something similar, you need to do two different things. First thing is you need to prove that's the same shape. In order to prove that's the same shape, you have to have these same angles. So it should be the same angles. If it has all the same angles, then the shapes are going to be the same. Second thing you need to do to prove it is that it needs to have proportional sides to each other. What does that mean? That means the sides must have the same scale factor. They must all have the same scale factor. So what's a scale factor? Let's go back to cool math guy. He's right here. Right here. Oh. All right, if we take cool math guy and we get rid of this one. Okay. Clarissa. Daniel. Okay. So if we take cool math guy and we increase them, it's going to be very rough, right? But we're going to say that is about twice as large, or it's more than, that looks about to be twice as large as this guy, right?
No.
Yeah, it's a little bit more than twice. Okay, whatever. We'll just move this a little bit. There we go. Okay, that's about twice as large. This image is about twice as large as this image. So what do you guys think the scale factor is going to be? 2, right? So it's got a scale factor of 2. All right, so let's prove that these two shapes are similar. First thing, let's see if all the angles are the same. Well, these two angles are the same, right? These two angles are the same. Let's check if these two angles are the same. Who's super smart and already knows the answer to that? Okay, Jonathan, do you think those two angles are the same? Why? Exactly. You are super smart. We know these two have to add up to be 180, right? These two have to add up to be 180. So if we have 180 minus this angle plus this angle, we should get our last angle here, right? I'm not going to calculate that out because I want to show you something. Let's do it here. 180 minus 59 plus 35. Is that the same problem?
Yes.
So are those two angles going to be the same? Yeah, they have to be the same. Does anyone know what theory tells us that? Very briefly, though. Third angle theory. If you have two angles that are the same in a triangle, the third pair of angles have to be the same. All right, so we checked all three angles. They're all good. We finished half the work. We still need to check the scale factor for each one of these. And spoilers, that one takes longer. Let's start with this. We're starting with 6. We'll make this into 200. Let's start with 6. We know 6 corresponds with, we know AB, which is 6, corresponds to what other side? B and C? E and D, which is 4. So we have 6 over 4. 6 over 4 is going to be 3 over 2. So we know we have a scale factor of 3 over 2. Or this triangle is 1.5 times larger than the small one over here. Okay, let's check out this one right here. This is 9 over, what's corresponding with this side that's 9? 6, which is 3 over 2 again. Let's do our last one. 10.5 over 7. Is that 3 over 2? How do you guys know that? You did the math. Okay, well, let's do it the proper way. This does not look to be the same, right? But are we supposed to have fractions and are we supposed to have decimals and fractions? Not really. Yeah, it's a 7. It's these two. Okay, we're really distracted right now. Okay, what I'm going to do is I want to get rid of this fraction, right? So I need to move the decimal over 1 point, correct? How do you move decimals over? You multiply it by 10. I'm going to multiply this top by 10 and the bottom by 10. You have to multiply the top and the bottom by the same number, right? I'm going to multiply both by 10. So that's equal to 105 over 70. Well, is 105 and 70, do they have a common factor?
Yes.
Of what? 5. 105 divided by 5 is 21 if you didn't know that. 70 divided by 5 is, no, 14. 21 and 14 are both divisible by what? 7. 21 divided by 7 is 3. 14 divided by 7 is 2. Look, they're all the same scale factor. So, is ABC similar? I mean similar to triangle? Yes, it is. We need to make sure we do it in the right order. A is the same as D. B is the same as E. And C is the same as F. And that triangle is most definitely right. Do you guys get it?
Oh, I get it. Wait, I get it. No, I did. I don't get it. It is definitely right. No, I don't get that. Because watch it on a dirt on your floor.
Okay. So, we need to see if these two shapes are the same. Well, I'm going to tell you right now Oh, they're not the same. Well, this one's smaller, right? So we're going to see if they're similar. Watch.
No, it's not. It is the same. It is not the same. Yeah.
Right? Those two shapes are the same. This shape is just rotated 90 degrees this way, right? Okay. When I do these problems, Valeria, Daniel, thank you. Blake. Okay, when I do these problems, these don't have numbers, right? So I like to line them up with numbers. What I use is this has one arc, right? Is there one over here with one arc? Yeah, it's Q. This has two arcs. Is there one with two arcs over here?
Yes,
This has three arcs. Is there one with three arcs over here? And this has four arcs. It's also four, right?
no, that's 3.
Oh, I'm sorry, I messed these up.
Yeah.
This one's 1, 2, 3, 4. This one is 4. This one is 3. Okay, sorry about that. Okay, I use that so I can get my orientation right. Okay, so do we have 4 pairs of congruent angles? 1 pair, 2 pairs, 3 pairs, 4 pairs, yes. So now guess what we need to check? The scale factor for the sides. Let's start with 25. Let's start with 25. 25 is right here. Or let's start with 25. 25 over, what is corresponding with 25? Well, let's look at it for a second. It is 15, but let's look at it. This is angles 1 and 4, right? So we need to look at this shape's angles 1 and 4. Do you see what I did? 1, 4, 1, 4. So that's going to be 25 and 15. Both are divisible by 5, so you get 5 over 3. So we think our scale factor is going to be 5 over 3. Let's look at this one. We're going to have 20 and, well, this is 1 and 2, right? 1 and 2 is 12. So that's going to be 10 and 6, which is the same as 5 and 3. Let's do 15. Oh, let's write this 5 over 3 so we know. Let's do 15 over, well, 15 is 2 and 3. Where's 2 and 3? It is right here. So that's going to be 9. Divide both by 3, and we get 5 and 3. Oh, wouldn't it be a shame if our last one didn't work out? And we did all that work and it was the last one. Man, I hope that doesn't happen. All right. We have 24 divided by 14.4. Uh-oh. Can you guys do 24 divided by 14.4 in your head? Okay. Yeah, we're going to multiply both sides by 10. I'm going to multiply both the top and the bottom, the denominator and the numerator by 10. 24 times 10 is 240. 14.4 times 10 is 144. Divide both sides by what? We can do 12, we can do 2, we can probably do 3. Yeah, we can do 3. I recommend 12. Yes. The 24 divided by 12 is going to be 20. 144 divided by 12 is 12. Both can be divided by 2 or 4. Let's do 4. So 4 would end up being with 5 and Are they all the same? Man, that would have been very awkward if... It's actually easier if they don't work out because you can stop on the one that doesn't. Does that make sense? J, K, L, M. So J is 1, so we're looking at Q. K. K is the same as R. L is the same as S. And P is the same as M. Okay. What was our scale factor? 5/3. Now I know my geometry. Nope. Shh. Leave it alone so you can concentrate. Nope. That's for Saturday. And I didn't do it. It was just for someone to use my room. Okay. Not similar? That's equation. That's 20. 15/9. Yeah. Okie dokie. These are the harder ones. We're going to go to the easy ones now. Easier ones. Okay. It tells us it straight up tells us it's similar. So we don't have to prove it's similar at all. We can use the properties though. We know this angle corresponds with this one corresponds with this one corresponds with this one, and this one corresponds with this one. Okay. We want to solve for x. We're going to set up a proportion. Proportions always look like this. I'm going to say big over small. What do I mean by that? I mean, we're going to put all the big numbers from this polygon on top, all the small numbers from this polygon on the bottom. We want to solve for x, so guess where I'm going to start? I'm going to start with x. Is x going to be on the top or on the bottom of this ratio? On the bottom, because it's part of the smaller polygon. What corresponds with x? Okay. Now I can choose any other number. I'm going to choose, I don't know, 12. Why did I choose 12 as the smallest one? 12 and 6. The biggest tip I can give you right now is before you even cross multiply, see if you can reduce. Can we reduce any of those?
Yes.
Which one can I reduce? 12/6, which is the same as 2/1. Now I can cross multiply. 13 times 1 is 2 times x is divide both sides by 2, and we get 6.5 is equal to x. Okay, you guys ready to get mad now? Watch this. 7 times 2 is? 6 times 2 is? 13 times 2 is? So what times 2 equals 13? 6.5. Okay. Blake, shh. Suni. Shh. Juan. Leslie. I'm going to start switching you guys around. Okay. This one here. I'm going to first start by labeling it. We have 1 arc, 2 arcs, 3 arcs, 4 arcs. 1 arcs, 2 arcs, 3 arcs, 4 arcs. Start with my proportion. I decide I want to go big over small. So let's look at our first one. We want to put, where's our x? Our x is right here. So we're going to have x plus 1 on the bottom, because that's probably the small polygon. What's corresponding to that? Well, that's 3 and 4. Where's 3 and 4? Oh, 9. Equals. What other choice do we have on this polygon? All we have is 5, right? So we're going to choose 5. What's corresponding with 5? 10 over 3. Uh-oh, this looks funky. Huh? So, cross multiply here. We're going to get 9 times 10 over 3 is equal to 5 times x plus 1. I want you guys to stop for a second. Can this be simplified right here?
No. Yes.
What's 9 divided by 3? 3 over 1. So we have 3 times 10 over 1, which is equal to 5 times x plus 1. 3 times 5 is, 3 times 10 is 30, is equal to 5x plus 1. Now there's a reason why I didn't distribute, Blake. Can we simplify this right now? Yeah, we can. We can divide both sides by 5. Divide this by 5, divide this by 5. Cancels out, and we get 30 divided by 5 is 6 is equal to x plus 1. Minus 1, minus 1, 5 is equal to x. Plug it in. So this is going to be 6. Sure, we'll do one more problem. All right. One more problem.
What's that for the Pluto's thingy, whatever?
Oh no, I must have got typed in. Yep. All right. Let's work on this one. Yeah, 5 equals x, sorry. All right, last one. This is 1, this is 2, this is 3, this is 4. This is 1, this is 2, this is 3, this is 4. Oh, there's 2 x's. Uh-oh. Let's do big over small. I'm going to start with one of my x's. I choose this x. Is it going to go on top or the bottom? X plus 6. This corresponds with this side, so 10 goes on top. Let's do our second x. Our second x is right here. X plus 9. What goes on top? Well, this is 1, 2, so we're going to look right here. That's 14. Cross multiply. 10 times x plus 9 is equal to 14 plus times x plus 6. Now, I would recommend simplifying this. Can we divide both 10 and 14 by 2? We would end up getting 5 times x plus 9 is equal to 7 times x plus 6. Distribute, distribute. We get, I'm going to do it right here, 5x plus 45 is equal to, distribute, 7x plus 42. What do you mean move them? Oh yeah, we're going to move minus 5x on this side. We're going to get 45 is equal to 2x plus 42, minus 42, minus 42, and we get 3 is equal to 2x, x is equal to 2 over 3. Oops, messed that up. Sorry, x is equal to 3 over 2. Alrighty, now we're done.